Installation, commissioning, and testing of a 3,000 metric ton Huisman offshore mast crane. Welcome to this exclusive, behind-the-scenes, look at the incredible process of installing, commissioning, and testing a massive 3,000 metric ton Huisman offshore mast crane. This high-tech, heavy-lifting giant plays a crucial role in offshore construction, from installing oil platforms and subsea structures to supporting the offshore wind energy industry. In this video, we'll take you through the entire journey, step by step, showcasing the engineering expertise, precision, and power required to bring this mechanical marvel to life. Step 1. Preparing for installation. Before the installation even begins, meticulous planning and preparation are required. A crane of this size demands a stable foundation, which means the vessel or platform it will be mounted on must be reinforced to handle the massive loads and dynamic forces involved in offshore lifting operations. Structural engineers assess the deck's strength, ensuring it can support not just the crane itself, but also the operational forces it will exert while handling enormous payloads. Simultaneously, the crane components, massive steel structures, sophisticated hydraulic systems, and intricate electrical wiring are transported from Huisman's manufacturing facility to the installation site. Each component undergoes rigorous quality control checks before shipment to ensure it meets the highest standards for offshore operations. Step 2. Installing the mast and crane base. Once all preparations are complete, it's time for one of the most challenging phases, the installation of the mast and crane base. The mast is the primary structural support, towering above the vessel and providing the foundation for the crane's lifting mechanism. Specialized heavy lift cranes are used to hoist the massive mast into position. This requires pinpoint accuracy, as even the slightest misalignment can compromise the crane's performance and safety. After the mast is securely positioned, the crane base is mounted onto the vessel. This base must be perfectly level and bolted down using high-tension securing systems to prevent any movement during heavy lifting operations. Engineers conduct extensive checks to verify alignment, stability, and weight distribution before moving forward. Step 3. Assembling the superstructure. With the mast and base in place, the next step involves assembling the superstructure, which includes the rotating mechanism, lifting booms, and the main hook block. The superstructure is the heart of the crane's movement and functionality, allowing it to lift, rotate, and position heavy loads with precision. This phase requires the installation of the crane's powerful slew system, responsible for its 360-degree rotational movement. The system's slew bolts must be meticulously tensioned to handle the extreme forces exerted during lifting operations. Engineers and riggers work together, using laser-guided tools and hydraulic torque equipment to ensure perfect installation. Step 4. Hydraulic and electrical system integration. Once the physical structure is assembled, it's time to integrate the crane's hydraulic and electrical systems. The hydraulic system powers the crane's lifting and luffing mechanisms, allowing it to raise and lower heavy loads smoothly. The electrical system, on the other hand, controls every aspect of crane operation, from precision movements to safety monitoring. Every connection is double-checked to ensure leak-free hydraulic operation and secure electrical wiring. The integration process includes connecting the crane's power source, hydraulic fluid reservoirs, and control systems. This step is critical, as any failure in the hydraulic or electrical systems can lead to operational delays or worse, hazardous situations offshore. Step 5. Commissioning and calibration. Commissioning is where the crane transitions from a static installation to an operational machine. This process involves running extensive diagnostics and system checks to confirm that every component functions correctly. Technicians begin by testing the control systems, verifying that commands sent from the operator's cabin translate into smooth, precise crane movements. Sensors and load monitors are calibrated to ensure accurate weight detection and safe lifting operations. The crane's emergency stop mechanisms, overload protection, and safety interlocks are all verified at this stage. Hydraulic pressure levels, slew movement, and luffing angles are fine-tuned to ensure the crane responds perfectly under real-world conditions. Engineers run simulations to test the crane's reaction to different load scenarios, checking for stability, efficiency, and emergency response mechanisms. Step 6. Load testing and safety verification. With commissioning complete, it's time for one of the most critical phases, load testing. This process ensures that the crane can handle its maximum rated capacity safely and efficiently. The test starts with smaller loads before gradually increasing to the full 3,000 metric tons. During static load tests, the crane lifts and holds heavy weights in place to assess structural integrity and stability. Dynamic load tests follow, simulating real offshore operations, where the crane lifts, moves, and places heavy loads under various conditions. Step 7. Certification and final approval. Before the crane can be declared operational, it must receive certification from international offshore safety and engineering organizations. Third-party inspectors review the entire installation, commissioning, and testing process, ensuring compliance with industry standards. Once approved, the crane is officially handed over for operational use. Operators receive specialized training to familiarize themselves with the controls, safety procedures, and emergency response protocols. The crane's role in offshore operations, now fully installed, commissioned, and tested, the 3,000 metric ton Huisman offshore mast crane is ready to take on the most demanding offshore lifting tasks. Whether it's positioning massive subsea structures, installing offshore wind turbines, or handling complex deep-sea construction projects, this crane plays a vital role in the global offshore industry. The combination of cutting-edge engineering, precision assembly, and rigorous testing ensures that this crane is not just a mechanical powerhouse, but also a symbol of reliability and innovation in offshore lifting. Final thoughts. The installation, commissioning, and testing of a 3,000 metric ton Huisman offshore mast crane is a testament to the incredible advancements in heavy lift technology. From the first bolt to the final load test, every step in this process reflects the dedication, expertise, and precision required to bring such a powerful machine to life. If you enjoyed this deep dive into the world of offshore engineering, don't forget to like, subscribe, and hit the notification bell so you never miss an update. Let us know in the comments what part of the installation process impressed you the most, and what offshore projects you'd like to see covered next. Installation of a 340 metric ton Huisman Pipelay system onboard Skandi Recife at Oord, Brazil. The installation of the 340 metric ton Huisman Pipelay system onboard the Skandi Recife at Oord, Brazil, marks a significant achievement in offshore engineering, underscoring the growing capabilities of modern construction vessels in subsea infrastructure projects. This advanced Pipelay system is designed to efficiently and safely install pipelines in deep-water environments, where precision and reliability are critical to the success of offshore oil and gas projects. The integration of such a system not only enhances the operational scope of the Skandi Recife, but also strengthens its ability to handle some of the most challenging tasks in subsea construction. The journey of installing the Huisman Pipelay system begins long before the physical work takes place. The Skandi Recife, a state-of-the-art offshore construction vessel, must first be fully prepared for the integration process. This includes extensive checks on the vessel's structural integrity and the configuration of its deck area. The deck is reinforced and equipped with the necessary mounting systems to support the Pipelay system's heavy load, ensuring that everything is in place for a smooth and efficient installation. Once the vessel is ready, the Huisman Pipelay system, which is composed of several key components including the Pipelay tower, drive systems, and tensioners, is delivered to the site in large modules. These components are massive, each designed to withstand the extreme pressures and harsh conditions of deep-water operations. To lift and position these heavy components onto the Skandi Recife, powerful cranes are employed, each with precise control mechanisms to ensure the safe and accurate placement of each module. Specialized rigging teams, well versed in managing such heavy lifts, guide the cranes to maneuver these massive pieces with utmost care, ensuring there is no risk of damage during the lift. After positioning the various components of the Pipelay system onto the vessel, the next step is integration. This is a meticulous process where the Pipelay tower, tensioners, and other systems are carefully aligned and secured to the vessel. The integration involves connecting the hydraulic and power systems that drive the entire system, ensuring that all components work in harmony. Each connection is rigorously tested to guarantee flawless operation once the system is put into use. This includes checks on the tensioners, which play a crucial role in controlling the tension of the pipeline as it is laid on the seabed, and the reels, which store and release the pipeline. These subsystems are vital to the overall performance of the Pipelay system, and their reliable functioning is essential for the success of subsea construction projects. Once the system is fully installed and tested, the Skandi Recife is ready to undertake complex pipelaying operations in deep water. The Huisman Pipelay system significantly enhances the vessel's capabilities, providing it with the advanced tools necessary to execute large-scale subsea pipeline installation projects with exceptional precision and efficiency. The system's robust design ensures that it can handle the extreme conditions of offshore environments, while its cutting-edge technology allows for precise control and seamless operations throughout the pipelaying process. The successful installation of the Huisman Pipelay system onboard the Skandi Recife represents a milestone not only for the vessel, but also for the broader offshore construction industry. It demonstrates the ongoing evolution of offshore technology, with vessels and equipment continually pushing the boundaries of what is possible in subsea infrastructure development. This installation is a testament to the expertise, skill, and collaboration required to meet the demands of the offshore oil and gas industry, positioning the Skandi Recife as a key player in the ever-growing field of subsea construction. Installation of 2 by 10,000 metric ton Huisman TMC for Heerema Sleipnir. The installation of two 10,000 metric ton Huisman traction machine cranes, TMC, aboard the Sleipnir, Heerema's state-of-the-art crane vessel, involves a series of meticulously coordinated steps, each critical to ensuring that the cranes are properly assembled, integrated, and operational for offshore heavy lift tasks. Tub 1 and 2 installation. The process begins with the preparation and installation of the tubs that will support the cranes. Tub 1 and Tub 2 are essential structural components that provide the foundation for the crane's subsequent assemblies. These tubs must be carefully prepared and positioned onto the vessel's deck, ensuring they are securely attached and balanced for the enormous weight of the cranes that will eventually be mounted on them. Crane House 1 installation. Following the tub installation, the first crane house is installed. The crane house is the housing unit that contains vital machinery and controls for the TMCs, and its installation must be done with utmost precision. Specialized lifting equipment is used to position and secure the crane house on the prepared tub. Slew bolt tensioning. Once the crane house is in place, the slew bolt tensioning process begins. This procedure ensures that the crane's rotation mechanism is securely fastened, allowing the crane to rotate smoothly during operations. The tensioning process is vital to ensuring the crane's full range of motion and operational stability. Winch Room 1 installation. The next critical phase involves installing the Winch Room 1, which houses the winch systems responsible for controlling the crane's lifting capacity. This room is also essential for controlling the tension and movement of the crane during offshore operations, and its precise installation is crucial for the crane's efficiency. Boom 1 loadout at Huisman, China. Meanwhile, the boom for the first crane, Boom 1, is being prepared for transport at Huisman's facility in China. The boom is a massive structural component, designed to lift and position heavy loads with high precision. Once the boom is completed and tested, it is carefully loaded out and prepared for shipment to Singapore. Luffing Frame 1 rigging at Huisman, China. At the same time, the rigging of the luffing frame 1, an essential part of the crane that controls the angle of the boom, is carried out at Huisman, China. This frame allows the boom to be raised or lowered, adding a layer of flexibility and precision to the crane's movement. The luffing frame's rigging process involves securing all the necessary hydraulic and mechanical connections to ensure proper functionality. Arrival in Singapore, boom and luffing frame 1 installation. Upon arrival in Singapore, the boom and luffing frame for the first crane are unloaded and readied for installation. The luffing frame 1 is installed first, followed by the installation of boom 1. This sequence is essential to ensure that the components are aligned properly and securely fastened before proceeding with the crane's assembly. Crane 1 installation. Once the boom and luffing frame are in place, Crane 1 is fully assembled and installed onto the Sleipnir. This marks a significant milestone, as the first crane is now operational, ready to perform offshore heavy lift tasks. Crane House 2 and Winch Room 2 installation. Following the completion of Crane 1, the installation of Crane House 2 and Winch Room 2 begins. These components are critical to the operation of the second crane, and their installation follows the same meticulous process as the first crane. The winch room lower and upper shaft installations are carried out, ensuring the winch systems are securely placed and tested for functionality. Boom 2 installation. Finally, the installation of boom 2 follows the same procedure as boom 1. The massive boom is carefully hoisted into position, connected to the crane, and rigorously tested for alignment and stability. With the successful installation of both 10,000 metric ton Huisman TMCs aboard the Sleipnir, Heerema's vessel is now fully equipped to handle the heaviest offshore lifting operations, including subsea platform installations and the construction of offshore wind farms. These state-of-the-art cranes provide Sleipnir with the ability to lift and transport the most massive and complex loads, reinforcing its position as one of the most powerful crane vessels in the world. Boom wire reeving. After boom 2 is installed, the wire reeving process begins. This involves running the wire ropes through the boom and winch system, allowing the crane to lift and lower loads with precision. The wire reeving process is critical to ensuring the crane can perform heavy lift operations efficiently. Crane 1 and 2 installed. The installation of the 3,000 metric ton Mount Huisman offshore mast crane onboard Ezra's Lewek Constellation. The Lewek Constellation, a DP3 class multi-lay offshore construction vessel, was purpose-built to handle complex deepwater projects, including subsea infrastructure installations and rigid pipelaying operations. To further enhance its functionality and competitiveness in the market, the vessel underwent a significant upgrade with the installation of a 3,000 metric ton Huisman offshore mast crane. This crane, known for its robust lifting capacity and advanced heave compensation technology, was designed to handle ultra-heavy loads with precision, making it a vital asset for offshore construction and decommissioning projects. Step 1. The installation of the 3,000 metric ton Huisman offshore mast crane on the Lewek Constellation. The installation of the 3,000 metric ton Huisman offshore mast crane on the Lewek Constellation was a complex and highly technical operation. This upgrade significantly enhanced the vessel's heavy lifting capabilities, enabling it to handle large offshore construction and subsea installation projects with greater efficiency. The process involved structural modifications, precision lifting, system integration, and rigorous testing to ensure seamless functionality. Before installation, the Lewek Constellation's deck and substructure underwent significant reinforcements to accommodate the crane's massive weight and dynamic operational loads. Engineers strengthened the main deck, added support beams, and upgraded the ballast system to maintain vessel stability during lifting operations. These modifications were crucial to ensuring safe and efficient crane performance in offshore environments. The mast crane was delivered in prefabricated sections and lifted onto the vessel using specialized heavy lift cranes. This stage required precision alignment, high-strength bolting and welding, and extensive non-destructive testing, NDT, to verify structural integrity. Once secured, the crane was integrated with the vessel's power, hydraulic, and control systems, ensuring smooth operation. The active heave compensation AHC system was also calibrated, allowing the crane to counteract vessel movements for precise subsea lifting. After installation, a comprehensive commissioning process took place, including static and dynamic load tests, to validate operational performance. These tests ensured compliance with offshore industry safety standards and confirmed the crane's ability to perform complex deepwater lifting operations. With this upgrade, the Lewek Constellation became one of the most capable offshore construction vessels, ready to tackle challenging projects in the oil, gas, and renewable energy sectors. Step 2. Boom installation of the 500 metric ton. The second step of the crane installation process is the crucial boom installation of the 500 metric ton Huisman offshore mast crane onboard the Lewek Constellation, a sophisticated heavy lift vessel operated by Ezra. This phase involves a highly coordinated sequence of operations to ensure both precision and safety. The process begins with the careful positioning of the crane boom. A specialized team of engineers, riggers, and crane operators prepares the boom for lifting. The crane's boom, an essential component designed to extend and lift heavy loads, must be precisely mounted onto the crane's main structure. This task involves using another crane, typically a smaller but powerful auxiliary unit, to perform the lift, ensuring that the load is balanced and aligned before any further actions are taken. Once the boom is in position, the team utilizes a series of lifting blocks, shackles, and other rigging tools to secure it to the main mast structure. The crane's boom is then gradually hoisted into place with meticulous attention to the angle and orientation. Proper alignment is critical to avoid mechanical strain on the crane and to ensure the structural integrity of the installation. Simultaneously, a detailed inspection is carried out to check the boom's secure connection to the crane mast and verify that all components are properly fastened. After the boom is securely in place, additional support systems, such as hydraulic systems and power cables, are connected, enabling the crane to function at full capacity. Installation of a 1,600 metric ton leg encircling crane on Aeolus for Van Oord. Get ready to witness an incredible feat of offshore engineering. In this exclusive behind-the-scenes look, we showcase the installation of a 1,600 metric ton leg encircling crane on Van Oord's Aeolus, a major upgrade that will revolutionize offshore wind farm and marine construction projects. Before lifting begins, engineers meticulously reinforce Aeolus deck to handle the immense weight and dynamic forces of the crane. Every detail is fine-tuned to ensure absolute stability for high-capacity offshore lifting operations. The most thrilling moment arrives as heavy-duty auxiliary cranes lift the towering mast and massive lifting boom into place. Precision is key. One wrong move could compromise the entire operation. Engineers use advanced rigging techniques to secure the components with pinpoint accuracy. Once assembled, the crane is powered up with state-of-the-art hydraulic and electrical systems. Engineers conduct rigorous safety checks to ensure flawless performance under the toughest offshore conditions. The final challenge, load testing. The crane is put through its paces, lifting and maneuvering extreme loads to confirm its operational integrity. Once certified, Aeolus is transformed into a next-generation offshore installation vessel, ready to tackle the industry's most ambitious projects. Subscribe for more awe-inspiring engineering content. Drop your thoughts in the comments below.